You're sitting in seat 23A, waiting for takeoff, when you hear the roar of the jet engines coming to life. It's a sound that's both familiar and intimidating, a reminder of the incredible power that's about to lift you into the air. But have you ever wondered how those engines actually work? What makes them so powerful and efficient, able to propel a massive machine like a commercial airliner through the skies with such ease? You might have a vague idea that it has something to do with combustion and airflow, but the details are probably a mystery. And that's understandable. Jet engines are complex machines with many moving parts and intricate processes. But the truth is, the basic principles behind a jet engine are actually pretty simple. And once you understand them, you'll have a newfound appreciation for the incredible technology that's at work every time you fly. So, let's take a closer look at how a jet engine actually works and explore the fascinating science that makes air travel possible. You're about to discover the surprisingly straightforward answer to this question, and by the end of this explanation, you'll be able to appreciate the jet engine in a whole new way. Vocabulary: turbine, combustion, airflow, propulsion. You're sitting in seat 23A, and as the plane starts to move down the runway, you feel a rush of excitement. But have you ever wondered what's actually propelling this massive machine forward? At its core, a jet engine is essentially a very powerful fan that blows air backwards, creating a forward force that propels the plane. Think of it like blowing on a pinwheel to make it spin. As you blow air backwards, the pinwheel moves forward, right? It's a similar idea with a jet engine, where the air is accelerated backwards, creating a reaction force that pushes the plane forward. And here's the surprising part. It's all based on a fundamental principle called Newton's third law of motion, which states that every action has an equal and opposite reaction. So, when the jet engine blows air backwards, the air exerts an equal force in the opposite direction, propelling the plane forward. This principle is what makes the entire process work. And it's the same principle that applies when you're blowing on that pinwheel, or even when you're swimming and you push water backwards to move forward. It's a simple yet powerful idea that's at the heart of how a jet engine works. And understanding this basic principle will help you appreciate the incredible technology that's getting you safely to your destination. Vocabulary: propulsion, Newton, reaction, acceleration. You're sitting in seat 23A, and as you look out the window, you might wonder what's inside that jet engine. Let's take a closer look. Inside a jet engine, you'll find four main components that work together to produce the thrust that gets you to your destination. The first one is the compressor, which is like a strong arm that compresses a spring. It squeezes the air, making it denser, and this process is crucial because it allows the engine to generate a lot of power. And here's the surprising part. The compressor is made up of many blades that spin at incredibly high speeds, pulling in huge amounts of air. The second component is the combustion chamber, where fuel is added to the compressed air and ignited, similar to how a car engine works. This is where the magic happens, and a mixture of air and fuel produces a small explosion that generates a lot of energy. The third component is the turbine, which is like a very efficient windmill that extracts energy from the hot gas produced in the combustion chamber. As the gas spins the turbine, it's like a windmill spinning in the wind, generating power. And finally, there's the nozzle, which accelerates the hot gas out of the back of the engine, creating the forward thrust that propels the plane forward. So, to answer your question, these four components, the compressor, combustion chamber, turbine, and nozzle, work together to make a jet engine work, and they're the key to understanding how a jet engine actually works. Vocabulary: compressor, combustion, turbine, nozzle. You're sitting in seat 23, and when the plane starts moving down the runway, and you feel that rumble beneath you, the jet engines are coming to life. But have you ever wondered what's happening inside those engines to create the thrust that gets you airborne? It all starts with airflow. As air enters the engine, it's compressed by the compressor blades, kind of like when you squeeze a stress ball. The air molecules are packed tighter together. Then, fuel is added to the mix, and the combination is ignited, producing a high-speed exhaust gas. This is where things get really interesting, The exhaust gas exits the nozzle at the back of the engine, and because it's moving so fast, it creates a reaction force that propels the plane forward. And here's the part most people don't know. The more air that's pushed out of the nozzle, the more thrust is created. It's similar to when you blow up a balloon and then let it go. The air rushing out of the balloon creates a force that makes it zoom across the room. In a jet engine, this force is what makes the plane accelerate down the runway and take to the skies. As the engine produces more thrust, the plane gains speed, and before you know it, you're lifting off the ground and soaring into the air. So, to answer your question, the combination of airflow, fuel, and ignition is what creates the thrust that gets your plane moving, and it's an incredibly powerful and reliable process. Vocabulary: nozzle, compressor, exhaust, thrust, propulsion. You're sitting in seat 23A when the plane takes off, and you might wonder, how does this jet engine manage to be so efficient and safe at the same time? Well, modern jet engines are designed to achieve efficiency rates similar to those of cars, which is quite impressive considering they're producing thousands of times more power. Here's the surprising part. Some jet engines can achieve efficiency rates of over 40%, which is comparable to a hybrid car. And here's how they do it. By using multiple compressors and turbines, the engine can optimize airflow and fuel burn, making it incredibly efficient. But efficiency is just one part of the equation. Safety is equally important. And that's where the multiple compressors and turbines really come into play. If one part fails, the others can keep the engine running, making sure you stay safe up in the air. It's like having multiple engines in one, providing a level of redundancy that's just not possible with other modes of transportation. And the result? Incredibly rare accidents, making air travel one of the safest ways to get from point A to point B. So the next time you're on a plane, you can feel reassured that the jet engine powering your flight is not only efficient, but also backed by numerous safety features. Want to learn more about how flying works? Vocabulary: compressors, turbines, efficiency, redundancy. So, you're sitting in seat 23A, and you've always wondered, how does that jet engine outside your window actually work? Well, now you know. It's a remarkable combination of air compression, fuel combustion, and turbine power that creates a high-speed exhaust gas, generating the forward thrust that lifts you into the sky. Think of it like a super powerful, high-tech version of a firework, where the rapid expansion of gases creates a massive amount of energy. And here's the surprising part. Despite their incredible power, jet engines are also incredibly efficient and safe, thanks to the numerous safety features and rigorous testing they undergo. You can feel reassured, knowing that the engineers who designed these engines have thought of almost every possible scenario to ensure your safety. Now that you've got a solid grasp of the basics, you can appreciate the incredible engineering that goes into these powerful machines. And if you'll never look at a plane the same way, you know what to do. Subscribe to our channel for more explanations and insights into the fascinating world of aviation, where we'll keep exploring the hows and whys of flying and make you an even more curious and confident traveler. Vocabulary: thrust, combustion, turbine, efficiency, engineering.